last presentation. We have David Hurster with us of Resources Global Professionals. We appreciate you taking the time to join us. My name is Patrick Shaver. I am with Intertek, and I will be the moderator for the event. Little brief history behind these events. We call them oxygen blasts. We've been doing them for quite a few years, but our customer base has grown quite a bit, and they're a lot more global than they used to be. So we use these as a way to reach out to all corners of the world. We've increased the frequency of them and also the topic ranges. So be sure to check out our website, or at the end of the presentation, I think I have a slide in there about what's coming up. So before I hand it over to Mr. Hurster to start for the day, I just want to give a 1 to 2 minute history behind Intertek. Our firm started around 1991, and we've grown to be the largest software and IT training and consulting firm in the state of Minnesota. And we've expanded both nationally and in the recent years globally. We've won over 35 awards for growth and top workplace best practices. Put simply, our employees love to work here and we produce good results. But with all that, our focus remains on customer satisfaction. So we've created kind of a unique model of instructors who consult and consultants who teach. Intertek has maintained some pretty stringent hiring practices that have helped us build a staff of highly experienced professionals that really empower Fortune 500 companies with software and IT innovation, as well as mentor, teach, and train their staffs. So good recipe for our growth and for our customers' growth as well. So with that, I think we can get started here. I'll be on Twitter managing any conversation out there. Our handle's @Intertek Inc. And I'll be using hashtag #OxygenBlast, all one word, for the event. So if you want to interact out there, I'll be there. Otherwise, feel free to ask a question via the chat panel on the interface there. So with that, David, it's all you.
Thanks, Pat. Actually, I noticed on a couple comments that people can't hear, so just want to make sure. Can anybody, if anybody's on the chat, can they just say, can they hear me or not? I guess if they can, they can say something. Okay. All right, good. All right. Well, thank you, Pat. Thanks for the introduction. Let me pull up my slide here, and we'll get started. Oops. Close that one down. Bring this one up. Okay. So, again, this is Expression Trees Creating Dynamic Link. My name is David Hurster, so my contact information is up here. So David at Outdoorways is probably the easiest way to get a hold of me if you have questions about the topics that we discussed here today. You can reach me on Twitter at David Hurster, and then the code that we're going to go through today is also located up on GitHub under my account. Agile.expressionsearch is the name of the repository. So with that, just a real quick brief introduction about who I am. So I'm a 4-time C# MVP. Somehow they keep rewarding me, so I'll take it. I do enjoy regional and local user events here around the Pittsburgh area and also in the Mid-Atlantic. So I'm a conference director for Pittsburgh Tech Fest. And I used to run the Pittsburgh.NET user group, and we're trying to start up a group called Steel Cloud here in Pittsburgh now. It's more of a distributed computing type of user group. And again, my Twitter, my blog, and my email are all there, and I'm occasionally on Stack Overflow too if you want to find me there. And then as Pat mentioned, I'm also by day I'm a senior director for web solutions for Resources Global Professionals. We're a financial services firm. Okay, so the problem statement that we're going to talk about today really revolves around using LINQ and trying to make it useful for you on the fly. So as we all know, LINQ is a pretty powerful tool, and honestly, it's ever since it was introduced in the 3.5 timeframe, it really was one of those catalysts, at least for me, and I'm sure probably for a lot of people, that kind of reinvigorated our interest in the .NET framework and really programming in C# and VB.NET in general. I know for me, like after a while working in .NET for a number of years, I kind of thought things were getting kind of bloated and big and bulky. And then when LINQ came out, LINQ with extension methods and lambda expressions, for me, kind of opened up a whole new world. Very eloquent and terse, but very powerful language constructs that really make your code, in my mind, very easy to read and extremely powerful, because now what used to take many lines of code, now you can kind of reduce into 1 or 2 lines of code, and you can also just make your code just do lots of really interesting things that I think before probably required a lot more thought, at least from my perspective. But the problem that we often see with LINQ is that LINQ, while it's powerful, is pretty strongly typed. And from that, I mean, if I have a sample here, so this is LinkPad, and I'm sure if you've used LINQ, you may have come across LinkPad in the past. So this is a free tool that you can download. It's built by Joseph Al-Bahari. He also has a great website, not just for LINQ, but also he has a great resource there for threading. So if you're ever dealing both with LINQ and threading, that's a good resource to take a look at. But if I had just an array of numbers and I wanted to query them, maybe pull out those numbers that maybe the numbers are less than 5 or greater than 10, I can't just pass in just a string, maybe construct a string on the fly to create this where clause in order to filter out my numbers. Basically, everything that I'm doing is pretty much hard-coded, so it's n is less than 5 or n is greater than 10, and it kind of boxes you in. And with this talk today, we'll kind of talk about this and how we can make this much more flexible so that you're not going through all these different gyrations in order to create fairly simple query statements based upon input coming from your user. So as you can see, we have a lot of examples that we're going to run through on LinkPad. There's just a simple little web API application that kind of illustrates that using JQGrid sort of as the client. So my problem statement really is I have this JQGrid component that sends search criteria to a controller. All the criteria that's being sent up to the controller is text-based. But I want to be able to take this information that's coming up into my controller and parse it out and create queries against my repository so I can get the right data back and present it back to my user. So I want to be able to use LINQ to whatever that might be, LINQ to entities, LINQ to SQL, or some Mongo provider, whatever that might be. How can I do that using LINQ? So to kind of take a look at my sample application quickly. So I have, if anyone's seen me present before, I really like baseball. So this is a simple JQGrid grid that just displays batting statistics going back to the early 1900s, I believe. So the data source, if you're ever interested in, is put together by Sean Lehman. It's a freely available database of all sorts of baseball statistics. So if you're a statistics person, check out Sean Lehman's baseball database, and you'll spend hours and hours going through the numbers. But anyway, it's a simple JQGrid that just lists out players, hits, doubles, triples, their salary, what team they were with, and what year they were playing, or what year this line of stats is for. And it's a functional grid. It's going out, it's pulling out different data, and I can change the number of rows per page and all that kind of fun stuff. One thing I would like to do, though, is I would like to be able to search. And so JQGrid has a nice search facility built in. It lets me kind of select all the different columns, or I can indicate which columns I want to be able to search, or I want to search on. And I say, well, home runs greater than 35. And when I hit search, obviously nothing happens because I haven't wired this up yet. So what's happening, though, if I look at my Chrome tools, is I can see that I have, within my query string parameters being passed up to my controller, JQGrid is saying, well, I'm doing a group operation. I only have a single rule that I want to filter on. The field I'm filtering on is home runs. The operation is greater than. The data I want to say is 35. So in a JSON formatted way, I'm saying, I want to see all the records that have home runs greater than 35. Simple. So JQGrid allows me to do that. And there's lots of other tools to do this. This is not a JQGrid specific talk. This just happens to be a tool that I've used in the past, and thought I'd present itself as a good sample. So I can say, well, let's also add together salaries that are less than $1 million. And we should obviously not get anything back because our search isn't working yet. But if I take a look at the query string that's being sent up, here's my filters. So again, it's adding these rules together. So now I have two rules. So there's a JSON array being passed up. I have home runs greater than 35, salary less than $1 million. So obviously nothing's happening with my results, and why would that be? So if I look at my HTML, I have a simple web page. I really have just two placeholders that jQuery is going to fill in my table and my pager. So really, jQuery is nice. It kind of builds the whole table for me. I don't have to worry about that. I just have to tell it where to put it. And again, I'm going to give you a real quick crash course on jQuery, but again, this is pretty simple. This is the URL that jQuery is getting the data from. So it's a web API call. It's the grid controller, and there's a method there called getData. This is my column model. So basically, this defines each one of the columns of my data. Again, nothing really fancy here. The only thing to keep in mind is that this index column is going to correspond to the column name in my repository. And my repository happens to be Mongo, but I've done this talk before with the repository being SQL Server. As long as you build your repository right, it doesn't really matter what your backend persistent store happens to be. So, but this one does work with Mongo, which is nice. And then each one of the columns, then I basically allow to have different search options. So my search options are little codes that jQuery knows about and basically presents to me English readable versions of those codes. So EQ is equals, NE is not equals, BW is begins with, BN is doesn't begin with, and so on and so forth. So the text fields have some more string specific operations. The non-string fields have just more numeric type of operations. So greater than or equal to, less than or equal to for my home runs column. Obviously, I have a copy and paste issue right there. So this is my HTML. The grid shows up just fine. So obviously, my problem is in my controller. This is where the problem statement comes into play. So here's my grid controller. This is my getData method that the jQuery is calling. And obviously, it's not doing anything because, well, I'm at a point that I don't know how to handle what's going on. That filters JSON that was coming up on my query string. I have an action attribute or an action filter that takes this and basically serializes it into a grid options class for me. That's all that this grid options does. So really, it's just the encapsulation of the filters that are being passed up from jQuery. So really, I don't do a whole lot here. I just figure out, well, how many rows do I need to skip in order to display within my grid? My baseball context, I'm just newing it up. What's the connection string to Mongo or whatever that happens to be. And then here is obviously the problem child. I am selecting everything from my extended batter table, and I'm just pulling back everything that's greater than 2005. I take the first 500, and I create a JSON string out of that and return it back to jQuery. So obviously, I'm not doing any filtering, I'm not doing any searching or anything like that, which is why we keep seeing the same results. So the problem is, well, if I'm getting just string representations of data coming up, how do I attack this LINQ statement here so that I am not just hard coding in year greater than 2005? How do I say home runs greater than 35 and salary less than $1 million and something else, or I want to do something else? And that's really the crux of the problem. That is the problem statement that we're going to address in this talk. And that's where things like expression trees really come into play. And those really become our best friend in trying to do something like this. Now, I will say up front, there is a library out there called LINQ. This sample, this talk is really based on a problem I had during my day job. And I did take a look at LINQ. It was sort of like this little library that was out there. It didn't seem like it was being maintained. It looks like it's been updated recently for the 4.5 framework. but it doesn't look like there's much of an owner around it. It doesn't look like there's much happening with it. If you look on Stack Overflow for Dynamic Link, there are people that use it. It seems like it works pretty well. But when I was trying to solve this problem, Dynamic Link to me was fairly new. It didn't seem like anybody really owned it. And from my perspective, it seemed like a black box. And I chose not to go down that path. I chose instead to look under the hood of Link and basically create these lambdas by hand because I wanted to have control over how those where clauses and order by statements were going to be handled. So I took it as a challenge, and also because I wasn't quite sure how a good dynamic link was going to be, because it didn't seem like anybody really owned it at the time. I could be wrong, but it's a good academic exercise to if you're interested in expression trees and how Link is really working under the hood. This is a really good way to practice and have some fun. So we've explained our problem statement, where we're trying to look, how we're trying to make this code better, more flexible, and be able to meet the needs of the client that's passing in data. So we're going to have to turn to expression trees to solve this problem. So expression trees. And again, most of this talk is going to be in code, which is why my slides are pretty minimal. Black text, white background. We only have a few more slides to go, and then the rest of the session will all be in code. But real briefly, what expression trees are, they represent code in a tree-like structure. So you can kind of infer that just by the name. But what they really do is they end up creating what's called an abstract syntax tree that represents your code. And abstract syntax trees are used in a couple places throughout the .NET framework, where we are dynamically modifying link statements sort of on the fly. The dynamic language runtime uses abstract syntax trees quite a bit. And then just in general, the dynamic modification of executable code are using abstract syntax trees. Basically, you're going in, examining that abstract syntax tree. If you just imagine what a tree graph looks like, you're taking one of those nodes off of your tree and modifying its behavior, and then allowing that tree representation of code to run again in a modified way. And we can create expression trees in one of two ways in our code. The first way is really simple. Just from a simple lambda statement, I can create an expression tree. It's nice. The .NET framework, by default, if I assign a lambda statement to a variable of an expression tree type, it will implicitly convert that lambda statement over to the expression tree. So that's the easiest way you can create a expression tree. And actually, in the code here, this where statement or this where extension method really takes an extension or an expression tree. If you've ever looked at the syntax for where, it really is an expression of type func that takes in an extended pattern and returns back a bool. It's not just taking a func, which is what we probably think a lambda statement or a lambda expression really is. So that's the easy way to create lambdas, but we're going to do the second way, which is manual construction of expression trees. So we'll be able to construct them using the abstract or the static expression class in the .NET framework, and then there's tons of static methods off of that allow us to easily create expression trees in our code. So if I look at a lambda statement like this one here, two variables x and y goes to x plus y, what does this really mean? What is this? So it essentially is a delegate. It's equivalent to a method that adds two numbers. It takes in two parameters, adds them together, and implicitly returns the result back to the caller if it's a func. And this is the beauty of LINQ in the .NET framework. Something as simple as this is very terse, very compact, but also very powerful, because then this actually acts as a variable that I can pass throughout my application. So this really becomes a first-class citizen of the .NET framework, just like a string or an int. And because of that, it becomes a very powerful construct within our code. And so keep in mind that throughout this, func is your friend. So as we already said, that lambdas are represented as an expression. This may look kind of ugly at first, but once you start looking at it, once you start seeing it, it'll become second nature to you, I guarantee you. But really, if you were to read this, signature basically says that I'm creating a lambda expression of type func, and the func is taking in 2 integers as parameters, and it's returning an integer. So the first 2 parameters here, or first 2 type parameters, are the inputs going in. The last one indicates what the return type is if it's a func. If it's an action, which is sort of the opposite, or in like a VB.NET world, it's a sub, there is no return type. These would just be 3 type parameters going into that action. So just keep in mind that that last parameter is always going to be what the return type is. So if we were to visually represent what an expression tree looks like, we can kind of start just by creating a very simple expression. So we have a variable x that goes to an expression of x times 2. So we're doubling, or we're multiplying x times 2. If I had to break this down into an abstract syntax tree, what would that look like? So it's real simple. Basically, it's 3 nodes. The first one is at the top. It's really the central action of this func. So it's the multiplication operation, which really ends up being a binary expression because I have a left-hand side and a right-hand side. The left-hand side is represented by a parameter expression, so basically something that's being passed in to my lambda. And then the right-hand side is the number 2. That's a constant. That's something that's fixed within this lambda, and so it's represented as a constant expression. The thing to keep in mind is that this entire expression is made up of expressions, and that is sort of the crux of creating expression trees. You really create expressions of expressions. Everything that you create when you start creating expression trees are just other forms of expressions. So we take a slightly more complex expression. So we'll have 2 variables, x and y, being passed into a lambda that just multiplies x times y. If we represented this as an abstract syntax tree, as what the expression looks like, again, just like the previous one, in this case, no, we don't have any constants. We have 2 parameter expressions. The left-hand side and the right-hand side are both being passed into the lambda. And the binary expression is really the operation that's being performed on them. It takes, what's the operation type? It's multiplication. It takes a left-hand side, and it takes a right-hand side. So pretty simple, right? But now if we start getting a little bit more complex, we probably think, well, our trees are probably going to get a little bit more complex, and you would be right. So if we kind of start on the simple side, our primary operation here is this multiplication. So that is our primary binary expression because, again, multiplication is a binary operation. It has a left-hand side and a right-hand side. The right-hand side is easy. It's a parameter expression. It's just y is being passed in to the overall function. The left-hand side, though, ends up being, again, its own little subtree. So it now consists of a addition operation, which again is another binary expression. It takes a left and a right. The left-hand side is a parameter expression. Again, the right-hand side is going to be a constant expression. This is number 2. And essentially, the .NET framework is going to evaluate these in an AST type of a way. So it really is going to take into account, go down left, evaluate my trees, bring them all together, and keep ascending up the tree structure. So when you start creating these types of expressions, order of operations becomes pretty important. You may want to structure your expressions the appropriate way because what you think, if I were to get rid of these parentheses and have x plus 2 times y, the way it would be evaluated would be the way I have it represented in this tree, which is not going to be the answer that you want. So that's a topic for another another session, probably the 102 version. But again, keep that in mind in terms of the order of operations. So if we had, let's say, a little bit more of a complex expression now. So I have, again, 2 variables being passed in, 2 parameters being passed in. It's going to add 2 to the first one and multiply it by y. So we'll assume that y is a string in this situation. So again, we break it down just based on how the expression looks to us. So obviously, the center of everything here is this multiplication operation. That's the kind of the root of our tree. Again, it's a binary expression. And you're probably getting tired of me saying binary expression, but again, this binary expression consists of a left-hand side, which is the addition operation, which then has its own left and right. And then the right-hand side is this method call expression. So again, expressions don't just have to be simple primitives. They can be calls to other methods. And we'll actually see that in the JQ grid example, where we'll call some string manipulation operations like to uppers and contains and begins with and things like that. So not only are you do you have access to primitive types within your expression trees, but you can also call out to other methods. And as we're seeing here, you can also call out to just members of other or members of a particular object. So in this case, I have the same type of expression, but instead now y is a complex type and it has a home runs property. And again, I'm really just calling a member expression on y to get the home runs property out in order to multiply it against the sum of x plus 2. So hopefully, as you can see, expression trees become very powerful. You do lots of really interesting operations with them. And in the process, you can also create extremely complex expression trees. And it could become very easy to get lost in your expression tree. So my recommendation is start simple and then start branching out. Don't try to tackle, like if you had to tackle this one for the first time, start with x plus 2, work your way up. Don't try to take the whole thing on all at once. And honestly, I think that's the end of my slide, which is great because we're all developers, we all just like code. So let's get into code. So what I was going to do next is, since we've already done, oh yes.
I just want to jump in. We had a question on whether the example project will be available for download somewhere after the talk.
Yes, it's already up in my GitHub repository, so you can download the whole thing from here. So if you just look for David Hurst on GitHub, it's agile.expressionsearch.
Awesome. Thank you.
You're welcome. And then I will also I'll be going through a series of LinkPad, just scripts, simple little code scripts. Those aren't up in GitHub yet, but I should have them up there hopefully by tonight. So, all right, that was the only question. Great. All right, so done with PowerPoint. I'm assuming everyone's applauding at this point in time. So going back to our grid example real quickly, I didn't really highlight this, but I have seen things like this in the past, and I'm not even going to run this code, but these are the things that I think expression trees tend to help you avoid. Long and gnarly if, else if types of statements. And obviously nobody wants to deal with this. But this is the situation that I think we all are trying to avoid and really get our cyclomatic complexity numbers way down. If I were to build this out for all the various operations and all the various columns that we could filter on or search on in that grid sample, I'm sure the cyclomatic complexity would be off the chart. So I'm not even going to run the code, but this is really a very bad example, and I would never recommend that anybody do anything like this. But I think we've all seen code like this, where we just do an if statement. If the operation is equals, do something else. If the operation is not equals, do something else. Also, if it contains, do something else. And those are, when you look at those are just terrible to maintain, terrible to look at, terrible to try to debug. And once we get into the final solution for this problem, we'll see that it actually becomes somewhat elegant. So even though keep in mind this is prototype code, so or proof of concept code is never elegant, but it's better than nested if else statements. Okay, so we kind of demonstrated what the problem is with LINQ, or at least the default out of the box problem with LINQ is that it's basically all hard coded in terms of being statically typed. Excuse me. So if we just take a look at real simple, I want to call a function or a method. It takes in 2 parameters and it returns back the product of those 2 numbers. Great. And LinkPad, very simple to do. And the nice thing is LinkPad has a nice little dump operation, nicely named, so it kind of gives me a nice little break in between my sections, and so I can kind of see, okay, the first operation's value is 20, the second one's 2. Great. So we're going to take a look at this product operation here for a couple scripts and kind of build on this. So if we take a look at this, so here was the old perform operation. If we went back to that, it took in 2 ints, it returned an int, but that's not really what we want to do. We want to make it a little bit more dynamic, because maybe I don't always want to multiply. Maybe I want to do something else. Maybe I want to add, or maybe I want to do something more complex. So we can modify perform operation to not just take in 2 integers, but also take in the operation that we want to perform on those 2 integers. So very interestingly, we can say, okay, perform operation now takes in a func it takes in 2 ints and returns an int, and we call it the operation. It takes the left-hand side, it takes the right-hand side. And what it does is it actually executes the func, passing in the left-hand side and the right-hand side. So now I'm passing around an actual chunk of code to other chunks of code, which is great. So you think function pointers, if you go way back, delegates, if you go to the early days of .NET, this is really obviously the next evolution of that. Calling that within my code, so in my main function here, I'll define 3 different funcs. So the first one is func with multiplication. So I'm going to take in 2 ints again, and I'm going to multiply it. I'm going to take in with a second func, I take in 2 ints, and I add them together. The third one, I'm going to take in 2 ints, and instead of just doing a single operation, I'm going to add 2 to x, I'm going to add 3 to y, and then I'm going to return the product of x and y. So I can have multi-line lambda statements, which is great. And really the only difference between the single line lambda and the multi-line lambda is I need to surround them in C# land. I need to surround them with curly braces, and I need to ensure that I actually have a return call in there. The return call on the single line lambdas is implicit. And so it's nice. So I can call perform operation, pass in the multiply func, and pass in 2 different ints, and it should multiply them. Same with add, and same with this one. But and notice now I can even say, well, I want to call the multiply func, and from my first int, I actually want to call the sum of 7 plus 3. So I'm actually going to pass in a func to my func to get it to execute my func. And then it'll add in 5. And even calling the multi-line func is no different than calling the single line ones. So you can get as crazy as you want. I could even say my func x, the keyboard's not working very well, 10, 20. And if I go ahead and run this, it all works. Pretty awesome. I'm not going to check the math. I assume that's right. But so you can nest these funcs within other funcs, which is great. So now it's like I have these little pieces of reusable code that I can just define once and pass them around, and I don't have to create these elaborate classes around them. And all I really need is just a simple formula. So that's kind of a brief introduction to funcs. And now what we want to do is we want to say, okay, this is great. I can clearly define pieces of functionality. I can pass them around. But now I want to be able to make these a little bit more dynamic, because once I define that my func m is x times y, I'm stuck with that. I can't make my func m without a lot of work become x plus y plus 2. Or I can't make it do something else. It's pretty much, I'm not going to say set in stone, but set in mud. And being able to change that requires a lot more work. It would be nice if I could just make this a little bit more dynamic up front, so that it could be almost anything I want it to be. Maybe home runs greater than 2 or 20, or salary less than $1 million. Be able to define what the property names happen to be and what the operations that are being performed on them are. So we'll go to the next stage of our samples here. So now from here on, we're going to be dealing with an array of numbers. So this one's probably a little bit more easy to get our heads around. Plus, it's very simple and it's easy to kind of take in all at once. And I like simple examples, so I think it's nice to be able to take a simple example and build on it. But this is really the operation that we want to work with, and this is the thing that we really want to try to make dynamic. So I want to be able to take, with this numbers array, I want to pull back all the numbers that are less than 20 or are greater than 100. So if I run this, obviously I'm going to get the numbers that are less than 20 and then greater than 100 being pulled back. Obviously, with this lambda, obviously there's a number of issues here that are makes things very static. Obviously my operations are static. I have this or in the middle that is also static, and then my numbers are kind of hard-coded in there too. But I'm sure you probably think, well, these numbers are easy to take care of, and we'll probably take care of that one first. And then I kind of did my lame attempt at ASCII art, but this would be the equivalent of what that expression tree would look like. The OR operation is sort of the root operation of this lambda. It then it's a binary operation, so the left-hand side, right-hand side are both it's their own binary operation. The less than has a left-hand side of x, right-hand side of 20. The greater than has a left of x and a right of 100. So there you go. That's it for ASCII art. And this is tough online because I don't know if anybody's laughing or people just think I'm lame. Anyway, next step. So what we want to do is we want to do a couple things. We want to make our predicate, which is really that lambda, less than 20, greater than 100. We want to make that predicate a little bit more dynamic. And so what we're going to do is introduce a little helper class called Predicate Builder. Now you don't have to use Predicate Builder. And Predicate Builder in and of itself is about, I think 20 or 25 lines of code. That's all it really is. But it does four things, and it does four things in my mind very, very nicely. It initializes either an AND or an OR operation for you. And then it allows you to tack on other expressions to an existing predicate very easily. And in those four operations, you can either start off with I want to do an AND operation or OR operation, and then I can either AND and OR other expressions onto my initial predicate. Those four things are very nice to do. Predicate Builder is a real nice little helper for that. Again, it's built by Joseph Al-Bahari, who's the guy behind LinkPad. And so if you go out to his site, the source code for LinkPad or the source code for Predicate Builder is there on his site. He has all 25 lines there. You can grab that. Or you can use a NuGet package called LinkKit. And I'm using that in the Grid sample app. So you can grab that off of when you pull it down from GitHub. LinkKit encompasses Predicate Builder, and then it has a few other little helpers for using Predicate Builder with Entity Framework and some other ORMs. So starting off with Predicate Builder here, because my overall binary operation is an OR operation, I'm going to start Predicate Builder with a false. So when I start Predicate Builder, I can either have false or true. And so if I'm doing ANDs, or if my predicate is an AND operation, I want to start off with true because I want to make sure everything is true within my predicate, and starting off with true is going to ensure that everything else after that true is going to be true in order for that AND to succeed. With false, that's the initializer basically for an OR type of operation. So obviously I need everything else, I need something other than the initializer for the predicate to be true in order for that predicate to succeed. So that's why I start this off with false for an OR. So just keep that in mind. It's true or false really initializes your predicate through Predicate Builder, and that's always the first step. So I'm doing an OR because my top level operation is an OR. So I've initialized my predicate, and now I want to tack on two additional expressions to my predicate. So I'm going to OR them together. So I'm going to OR x less than 20, and I'm going to OR x greater than 20, x greater than 100 onto my initial predicate. So basically what this predicate looks like in pseudocode is something like false or x less than 20 or x greater than 100. So obviously if x less than 20 is true or x greater than 100 is true, then the predicate will return true. Otherwise, it will return false. So I go ahead and I create my predicate, and then now this predicate is just a variable, and then I can pass it right into my where extension method and then it will behave just like this predicate. So if I go ahead and run this, we'll close this up. Again, we get the same list of numbers together. So obviously, it's a little bit more code right now, but once we get a little further on and make things a little bit more generic, this will be a small price to pay. So again, less than 20, greater than 100. And the nice thing too is with LinkPad, we can also take a look at very easily what's actually inside that predicate. So I've dumped out the contents of the predicate. Basically, it's calling a toString on the predicate. And if you're, this is a great tool to prototype fairly complex queries that you're running. And if you ever run into some issues or you have any results you think you should get back, this is a great way to start debugging and really digging into, well, what's really happening inside the predicate that I'm creating. So you can see here that at the very top level, it's kind of giving this debug view of what my predicate looks like. So again, it looks like false or x less than 20 or x greater than 100 is what that expression is being constructed as. And then I can dig into the different pieces of this expression in all of its glory down here. But we won't deal with that right now. So we can now tack on as many of these or predicates as we want. So if I wanted to, I could even tack on another predicate to my overall predicate, saying, okay, predicate.or maybe x greater than or divisible by 3 or something like that. So I can keep tacking those on, and they'll just be ORed together. So I'm not limited now in terms of having a very static type of expression where I'm filtering on. I have a little bit more power and flexibility in terms of what I'm filtering on. But I'm still limited now in terms of what these lambdas look like. So I'm still left with a greater than and a less than symbol and these hard-coded numbers. So now we need to start making this a little bit more flexible. So here we go with the next step. So we still have our same array of numbers. I'm going to initialize my predicate, and since I'm ORing them together, but now I've created two other methods. I've created a get less than and get greater than. And so now I'm being able to pass get less than 20 and get greater than 100, and it will construct the same predicate for me that we did in the previous snippet. So this is kind of getting there, but again, the same problem exists. I have basically the same lambda that I had up here, except now I've just moved it, I've encapsulated it into a method. And that might be, you might think, well, that's kind of silly because now I'm going to have an explosion of small little methods that do various mathematical operations. And that's true, but we'll tackle that here in a moment or two. Again, if I run that just to prove that everything still runs, we get the same list of numbers of less than 20, greater than 100. So let's move on to the next step. Now we're going to start breaking things out. We're going to make things a little bit more dynamic. We're going to start creating these lambdas on the fly. And this is where it starts to get, I would say, a little heavy. So again, same list, same array of numbers, same initialization of the predicate because we're doing an OR. And so now I'm going to say, okay, predicate OR. And now I have a single method called getComparison. And what I'm passing in is the number that I'm comparing my number to that I happen to be iterating through. So I'm going to be comparing it to 20. And the operation that I want to compare it to now is an expression type. So in the expression namespace in the .NET framework, there is a enumeration called expression type. And it has, I'm going to just guess and say between 50 and 75 at least, different operations or different expression types that you can have. So most mathematical operations are in there. So less than equal, greater than equal, equals, not equals, all that kind of stuff. They're all in there. And so I'm going to say, well, I want to call getComparison with a less than operation the first time, but I want to call getComparison with a greater than operation the second time. So getComparison is going to do that for me. So what is getComparison doing? So let's take a look. So getComparison is a lot like the perform operation, except for now, we are passing in a right-hand side. So that's what we're going to compare the particular number that we're working with, 2, and we're going to perform a particular operation on that. And what we're going to return back is an expression tree. So we're going to return back an expression of type func that takes in an int and it's return a Boolean, because this is the signature basically that where extension method is looking for. So now we start constructing our expression tree. So if we remember from the PowerPoint slide, with a simple expression, the binary operations up the top, but I need to construct my left-hand side, my right-hand side first before I can add them into my binary operation or my binary expression. So my left-hand side is my parameter expression. It's what's being passed in to the expression. I think I have this laid out kind of well over here. Basically, this is my left-hand side. I need to define x as a parameter going into my expression. So it's a type int, and just for friendly name, I'm going to call it x. The right-hand side is going to be just a constant expression. It's what's being passed in to get comparison. So in this case, it's 20 or 100. And so it really just represents a specific, just a number. So I have my left-hand side parameter and my right-hand side parameter defined. The next step is I need to create a binary expression that brings left and right together and brings them together under a comment operation. So again, the expression static class in the .NET framework has a number of methods on it. This one is called makeBinary. What makeBinary does is it takes in what's the operation that I want to perform. So in this case, it's a type expression type. And first time I want to make I want to call less than. Second time I want to perform a greater than operation. And so because it's binary, I need to have a left and a right. So my left-hand parameter is here, my right-hand parameter is there. And once I call this, I basically end up with a binary expression coming back. So this binary expression still is kind of in a metadata state. It's not anything that's executable just yet, because it's still just sort of a high-level definition. Think of it as the class definition in programming. It's not an object instance yet. And that's what this next line will do. Basically, we're going to take this expression tree and create a lambda expression out of it. So what this lambda call, the static off of expression, is going to basically do is say, all right, I'm going to pass into you, what I'm doing is I'm creating a lambda expression that is going to be a func, and it's going to take in an integer, and it's going to return back a Boolean. And the expression metadata, that blueprint for what this lambda looks like, is contained within this binary expression tree. And this left-hand parameter is what's being passed in. It's the x that's being passed into my lambda expression at that point. So I call the static lambda off of the expression static class. I get my lambda back, and now I can return lambda back to my calling code. And so now it's a expression of type func that takes in an int and returns back a Boolean. That satisfies my OR off of predicate builder. And so I can tack this now onto my existing predicate and keep going. So I've now dynamically created an expression, and now I can really pass in any kind of type or any kind of operation that I want. I could do greater than or equal to, less than or equal to, multiply, add them, doesn't really matter. It's pretty powerful now. I can start really making this a little bit more flexible. So hopefully that makes sense so far. There's 2 more snippets I want to go through, but I want to see if there's any questions so far before I go into the next 2 snippets. I haven't checked the chat yet. Is everything good out there, Pat?
I don't see any questions.
All right. So everybody's asleep, or this makes complete sense. So we'll see. Okay. So I want to take a slight detour here and just take a look at, we've looked at predicate builder and creating sort of a single lambda statement, x less than 20 and or x greater than 100. But what if I wanted to do x less than 20 or x greater than 100 or a nested predicate, or x greater than 50 and x less than 90? Maybe I wanted to do something like that. So something that represents this type of expression. So this one gets a little bit more complicated, but it also gets more complicated because now I sort of have this comparison inside a greater comparison that's going on. And the nice thing is that Predicate Builder handles this quite well. What I'm going to do down below is really just create a new instance of a predicate using Predicate Builder, and then tack that predicate that we end up creating onto this main predicate. So again, we're going to still use our get comparison operations or methods that we created before to create the less than 10 and greater than, oh, I said less than 10, greater than 200, whatever that might be. But we'll create the first two pieces of our predicate the same way we did before. But this last piece, this nested predicate piece, I'm actually going to punt that off to another method I created called getBetween. So what getBetween is going to do is it's going to take two ints and return back again another func or another expression tree. So getBetween is an int that takes in the lower and the upper, and again, as I said, we're going to use Predicate Builder again to initialize a new predicate that will then return back to the main predicate that gets tacked on. But in this case, since we're doing an AND operation, because I want only those things in between 50 and 90, I need to initialize this new predicate with a true, because I want everything else after it to be true in order to satisfy the predicate. So I'm going to say, well, Predicate Builder true initializes up my AND predicate. And then for my inner predicate here that I'm working on, I'm going to build on top of that calls back to, hey, get comparison. So now I'm reusing this same logic that we use to create individual comparison operations, and we're going to reuse it back within getBetween. So again, get comparison 50, greater than 50 and less than 90. But notice that here in this case we're ANDing them together instead of ORing them. But the nice thing is that this same code now can be used to call get comparison directly, or just be part of another chain of calls that just relies on expression trees being passed back and forth. So as long as they're all the same signature, everything's cool. So this is the same type of thing that we saw very early on in, I think, in this snippet here, not this snippet here, where we're passing in funcs to funcs and to other funcs. The same thing you can do, we're doing the same thing here. It's just because we're nesting predicates inside of each other. So I have about 10 minutes left, so I want to kind of get this into the high gear a little bit so we can get the grand finale with the JQ grid stuff. So again, this will all run. I suspect unless I have a typo somewhere. Oh. And I get my numbers of less than 10, in between 50 and 90, and greater than 200. So the last piece here, so if I looked at the last snippet before this, this works great. So we're able now to create expressions. We're able to create these things really nicely. The big problem that we still have, though, is that we still have a hard-coded reference in here. And it's not really the hard-coded reference of the expression type or the operation that we're performing or the values being passed in, but it's the type that we're working with. So we're always working with integers in this case. Well, what if I wanted to do something else? What if I wanted to deal with letters or maybe more complex types? Well, in this case, I'm stuck with int. So I need to make this a little bit more generic. And of course, it's really easy to do. So we have an array of numbers and we have an array of letters. And what we're going to do is we're going to do the same thing we did before for the numbers. We're going to do the x less than 10 greater than 200 and in between 50 and 90. Great. That's awesome. We don't have to walk through that again. But now we want to do where the letters are less than C or greater than O or in between F and J. And I'm going to use the same methods that we created before, the get comparison and the get between. But in this case, we're going to be using chars. It's a silly example, but I think it illustrates that you're not tied down to specific types. We can make this all generic. So now my get comparison is a generic method. It takes in a type T, and the expression tree that returns back is going to be of type T that's being passed in, and always we're going to be returning a bool. The only thing that's a little bit different is that my parameter definition, I just need to make a minor reflection call to get the type of T that this parameter is going to be. Otherwise, everything else is pretty much the same code. Same thing with get between. Get between is a generic type. Doesn't matter what these types are as long as they basically are comparable types. So I'm passing into get between a lower and upper T, and then I end up calling get comparison again, and everything is pretty hunky-dory. So if I go ahead and run this, and we'll see that we get the same result we did before, and then we get letters less than C, in between F and J, and greater than O. So pretty interesting and pretty powerful. Hopefully you can see how powerful expression trees can be. And once you kind of get your head around what's really happening and understanding how expression trees are built within code, you can actually really start creating really crazy things in your code, but really making your code much more dynamic and flexible. So I'm going to go back to Visual Studio here. Actually, I'm going to go back to my third example. Oops. Here. So we'll go to the finale for JQ Grid. So here's my JQ Grid, the third iteration of it. So again, everything works nicely. But now in this case, I have sorting enabled, which is great. And I also have searching enabled. So I can say home runs greater than 50 and salary less than, let's say less than equal. Less than or equal to $1 million. Oops. And I'll go ahead and search this. And I'll see the numbers change. So we know it must be right. I think I have a bug here, but we'll take a look at the numbers here, at least for the home runs. And I'll have to look at the salary. I'm not sure what happened there. But anyway, so obviously I'm searching on home runs, and it returned everything back. So in the first example, this didn't happen. Nothing really was executed. So how do we enable this with this third example? So that JQ Grid is calling the getData3 method on my web API. And we won't worry about the sorting piece as much. But this is really the code. This is really what's happening in here. So again, we have our grid options being passed in. We figure out, what page of the results we want to show. Still the same baseball context, so it's still going against Mongo to get the data out. But now I'm defining an expression right in my code here that says that my predicate that I'm going to be searching on is going to take in an extended batter type, which is really just a representation of the values in this grid. And it's going to turn back a Boolean, which is what the where extension method off of my queryable requires. So if I am searching, what I'm going to do is I'm going to create this predicate. So I have a class called search helper. And what search helper is going to do is basically do the same thing we walked through with LinkPad. So we don't have time to go through all the details here, but if we look at search helper, if you take a look through the code, it's pretty similar to what we were doing in LinkPad. Granted, it's a little bit more complex, but not terribly so. Obviously, what's being passed in through the grid options that was coming in from JQ Grid is, well, is this operation an and or is it an or? And so if it's an and, just like we did in LinkPad, I start off my predicate builder with a true. Otherwise, I'm starting it off with a false. And also notice that I'm dealing with generic types. So even though we're dealing with batters at this point, I could use the same type of code for pitchers or fielders or pizza flavors or whatever that might be. The same type of logic is pretty much generic enough that there really aren't hard-coded values in terms of what the field names are or the column names or type names along the way. So I looked through my filter rules. And so if we remember from what we were seeing in my debug, my filter rules are here. These are my rules. This is what JQ Grid is passing into me. Based on the client that you're working with, it could be anything, but I'm tailoring this to JQ Grid. So I'm searching on home runs greater than 50 and salary less than or equal to 100. So I'm basically creating two predicates and adding them together. So I go ahead and I figure out what my rules are. I figure out what the property being associated with it is. And again, just like we did in the last stages of LinkPad scripts, I need to create a parameter expression, and all it is just the type that's being passed into my expression that's going to be compared on. And then I have a constant expression on the right-hand side that is saying, well, the home run number is going to be, it's 50, or the salary being compared to is $1 million. It doesn't really matter. I just end up calling this against a particular property. Here, if I deal with strings or things like that, I can actually call out to other methods to invoke maybe manipulation methods on strings or whatever that might be. I don't really have time to touch on this right now because we're running out of time, but we'll leave that as an exercise to the listener. The key part here is really what's going on with the binary. So I still am tweaking this a little bit, so this isn't the best code in the world. But at least it presents you what's really happening. So let's say it's a binary comparison. So home runs greater than 1 million, or home runs greater than 50. So my operation attribute expression type, just like we saw in LinkPad, it's going to be a greater than or greater than equal or less than type of operation. My left-hand side is the home runs property, which we grabbed up above. The right-hand side is the number that I'm comparing it to, 50 or 35 or whatever that might be. And it basically creates, at that point, a binary expression. So I take that binary expression, just like we did in LinkPad, and I create a lambda off of it. So I take that binary expression, which is that blueprint for what my lambda is going to be like, and I'm taking that blueprint and saying, this is the parameter that blueprint goes to. I end up creating my lambda. I tack my lambda on to my overall predicate. So if I'm in an and situation, I'm anding it. If I'm in an or situation, obviously I'm oring it. And basically, I just keep looping through all my filters until I am done. And I've built up this predicate, and then I return it back to my controller. My controller gets the predicate, and then all it does is just sticks it into my where extension method, executes the LINQ query, and everything is great. Excuse me. You will notice that this is as expandable call here. This is a Predicate Builder link kit thing. If you're working with Mongo or any framework, you're going to need to call this. This basically just takes your context and makes it sort of in line with the way the Predicate Builder builds out its predicates. It's a really minor thing, but there's documentation on Joe Abelhardy's site about that. So again, I end up executing my my where extension method. I filter out my extended batters. I have my results enumerable coming back, and then if I want to sort, I can go ahead and sort and basically do the same type of sorting that I did through search helper. I can create my order by clause pretty simply. I think that code for order by is even simpler. Yeah, and basically this looks like I almost lifted it right on LinkPad, which is pretty much where I built a lot of this stuff first, because I used LinkPad as sort of my sandbox before actually writing the real code. But yeah, again, the same type of thing. I grab the property that I'm sorting on, I create a parameter expression for it, and then I basically just say, okay, I need to create an actual property expression or a member expression for the field that I want to sort on. And then I just created a lambda off of that. So again, pretty simple, pretty straightforward type of stuff. And again, since it's all just expressions at that point, I can just tack it right onto my enumerable, my queryable, and just let it keep tacking all the stuff on. And then once I start iterating through my results, then really is when everything ends up getting executed in sort of a deferred way. So in a nutshell, that's basically how you can start making your link statements more flexible, more dynamic on your own by taking advantage of expression trees and the power that expression trees really gives you within the .NET framework. Obviously, there are libraries out there like Dynamic Link that let you just pass in a string and it parses all that out for you. But my guess is that what Dynamic Link is doing is a lot of what this is doing right here. Is is parsing out what that string is, figuring out the binary expressions, the unary expressions, my left-hand side, my right-hand side, and joining it all together. There's a lot more behind it, but this is probably just scratching the surface, but it gives you a lot to go with. And again, hopefully this was helpful to everybody. That's pretty much what I have. I went about 5 minutes over, so hopefully it's not too bad. If there's any questions, definitely open to taking them, if there are.
Yeah, I don't see anything up there right now.
Okay.
I think we're
good.
David, if you want to throw up that last slide, just let everyone know about upcoming. Our next one, September 3rd. It's focused on .NET, and then I think in October we're going to have one on the new Swift language for Apple, as well as a Scrum Blast as well. So, and then there's some opportunities for training on our website in relation to what David was speaking about. So, David, thank you. That was awesome.
Oh,
I appreciate it.
Is there anything else about this? Oh, there we go.
No, that's good. That's good. So, thank you everyone for attending, and David, thank you for your time.
Oh, you're welcome. And again, my contact information is up here if you guys have any questions, and also the link to the JQ Greek code and the LinkPad stuff will all be up in this repository shortly.
One more chance for questions. Anybody?
Going.
I think that's it, David. Thanks.
All right. Hey, thank you, everybody.